In realms beyond our own, a mirror's gaze, reflecting worlds in countless mystic ways, where echoes of our choices, lives untold, in parallel dimensions manifold. A mirror universe, a looking glass, where what is real and what is not may pass. A place where time and space dance hand in hand, and destinies diverge, a shifting sand. Inverted lives, where shadows take on the stage, an endless cosmic surreal pilgrimage. A subtle twist, a subtle turn of fate creates a world where all can fluctuate. In one hero's tale, a legend's bloom. In another, darkness shrouds a different room. A chance to see ourselves in different light, to ponder what is wrong and what is right. But do these mirrors hold a truth profound, or merely illusions of worlds unbound? A glimpse into cosmos' grand design, or just a trick of light, a thinning line? Mirror universes, secrets to unfold, the mysteries of existence yet untold. In every glass, a story to be seen, where endless possibilities convene.
Nice.
Wow, that was surprisingly not horrendous. And you know who wrote it? Not me. That was AI doing its fine work in the last 5 minutes, I would say, just writing a poem just like that. Why? And prompted it, write me a poem about mirror universes. All right, so, but before we go on, like, what
But
is
like,
this?
well, yeah, what are we doing here?
What are we
Who,
doing
who
here?
who are you, and what do you think you're doing?
Well, I'm Shen, and I'm currently, SG2 on Space, the only weekly space show. Find it youtube.com/Shen Ge/streams. Um, Disembodied voice in the background. Let's bring him on. Who's this guy?
Hey, Shan.
But not Neil Torek. All right,
I
so
didn't do that. You did that.
I did that. I thought it
Yeah.
was better than Doctor of Love. Although we can always change it back to that if you want.
Hmm.
Um, so uh,
How,
yeah,
how are you doing?
I'm okay. I'm a little hungry, so after the show, I definitely want to get some food. But we're doing episode 196, as noted.
Wow.
This is Dr. Leonard
You
Kramer and
know, in a
myself.
month it'll be 200.
I know,
You
remarkable.
know, yeah.
Yeah. For our listeners out there, that is 10,000 years into the future. If you're watching this,
Hmm.
realize that this is the year, according to our calendar, what Gregorian calendar, 2023. Uh, what is it?
I
November
think it's
8th.
the 8th. Yeah,
Yeah, November 8th.
November 8th.
Yep. And we're on our current planet is Earth, which is in the solar system, what we call the solar system, in the
I think the
spiral
name.
arm.
I think the name of our star is called Sol
Sol, right? SOL.
or
Yeah. So
Sol.
10,000
Yeah.
years from now, if you're wondering what star system we're in and what planet, this is where we are.
Hmm.
So Earth should ideally still exist at that point, but I don't know. Um, but in any case, today we're talking about a grand topic as well. Primarily, it's a very general topic called Neo-Torek's talk. So, oh yeah, before I truly go on, guys, support the show, patreon.com/SG2 on space as always, and please, what is it? Like, subscribe, and all that stuff as well. And as well as I got to thank you to our supporters, Patreons, Kyle Baker, Sam Welsh, and lastly, Atum Ra, who is the producer for 2 years before I started doing this on my own with Leonard. So with that said, let's talk about who this Neo-Torek guy is, who is not Leonard. So
Take that away.
all right, I'm going to remove that, but I'm going to remove that, not Neo-Torek. But who is Neo-Torek, and what are some of his interesting
Right.
theories?
I only recently became aware of him. Uh, um, he's he's a physicist, well established physicist, and I think that he has a gig at the University of Edinburgh in Scotland. And so I came across a couple of YouTube videos with him, and I was kind of astonished at a different kind of take on the physics that we've been hearing about from many of the other popularizers, and that he makes this case that actually the universe is very simple on all kinds of different scales, and that the equations that scientists, are the in modern physics, the physicists that have made the most important contributions to our understanding have equations that you can write on a single page. And he cites uh, James Maxwell, who we talked about once, and Einstein and others. That you can encapsulate a lot of information in just little pieces of uh, the theoretical understanding. And he contrasts that with this tendency. So this tendency to add more and more complexity, and hence string
You,
theory.
yeah, I
And
mean, I know you've railed against string theory
and and
before.
and,
What?
and well, I
Go
don't know
ahead.
if I rail against it. I mean, I was open to it, but then I started realizing that a theory about everything, and string theory kind of came online in the 70s and 80s. And we started, and of course, we knew about dark matter and we knew about dark energy around that time. And dark matter in particular became a thing that we really started to appreciate in the late 90s. Well, where is string theory there? I mean, you would think that a theory of anything, and I've said this before, that a theory of everything that explains all the particles and everything, that there would be some little piece of that theory that you would look down in the corner and go, hey, what is this?
Hmm.
Oh, that would be like some kind of dark matter. That would be some kind of matter that doesn't interact with other kinds of matter. But it wasn't there. It has to be kind of grafted in as new observations are made. They adjust the theory to make it produce the results that they want. And it's gotten so ridiculous that people are extolling this idea that we have multiverses. Well, when the universe is created, then we can have any kind of universe at all. And so that, having multiverses, an infinite number of multiverses in order to explain the theories, it has no explanatory power at all.
Right.
It's actually not even a theory. And so,
So essentially, you're saying like a good theory should be able to. Let me bring my face
yes,
in here so I'm not
yeah,
disembodied. So a good theory should be something which could predict things, right?
which,
That doesn't
uh
exist. I
huh,
mean, that previous
right.
theories would not account for it.
And
Yeah.
and so and so and so that's why I was kind of excited to come across Neil Turok,
What is his
because
theory called,
well, his theory called,
or
well,
whatever it
I
is?
don't know that he has a particular. I don't know if he has a theory that it's called, but
Hmm.
he has an idea about the nature. Well, recently he has this. I actually don't know the name of the theory, but he has a kind of a mirror.
Ecaprotic?
Oh, okay.
Caprotic
Ecoprotic.
universe?
Okay, so that would be like he has these ideas that there are these fields and that they collide and
Let's
then
see if I can share
create
this.
create the universe. And so, but he has equations where he makes predictions, and so he actually has an idea that, well, time goes forward. We have time going forward, but then there's a kind of a reciprocal time that goes backward. And so I never came across this before. So
Right.
effectively, the universe has forward time, and then there's backward time, which is symmetric. So we have like a symmetric mirror that's not exactly in the past, but it's sort of in the opposite time direction to the one that we're following. And
That is so
and
weird.
and it has a lot of and I don't understand the deep physics, although I'm kind of working on it, kind of interested enough to really try to get into that. But he has an explanation for dark matter. He says that um, it's a what they call right-handed neutrino, which is one of the particles that is which is um, which is posited to exist, and so it has a high mass. So that the neutrinos are an explanation for where the dark matter is, and that's actually something that kind of like I kind of had this kind of intuition about it. But the thing is, he's trying to ground his whole research his
Mhm.
whole research um, uh, project, and he's at a place called the Perimeter Institute, which is in Waterloo, Ontario, in Canada. So he has connections there, and he has connections at the University of Edinburgh. He came from South Africa. He created some
So
kind of
he's
African
currently.
math. Yeah,
Sorry, go ahead. I
he,
need to
he
stop.
made some kind an African math institute, or network. And so but anyway, I just wanted to talk about him because I thought that the things he was saying were pretty cool. um, he says he wants to only have the simplest of theories to explain and make predictions that can be tested. And that's where I am, so.
So, I mean, the thing is, what could we predict? What can we predict with this theory that we wouldn't? I mean, what can prove his theory? Or
Well, he makes predictions about the dark matter, and one of the consequences of the dark matter is that this other neutrino has to have, based upon the mechanism that he's come up with, there's a left-handed neutrino that is well known, right? And and what left-handed means is that the polarization is circular and rotates in the direction of motion of the neutrino, the way the left, like if your thumb is pointing with, and this is my left hand,
I can
it
tell.
rotates in this direction. So he says that there's a right-handed right-handed neutrino, and they oscillate back and forth according to a kind of boson interaction, and that it makes the prediction that this other left-handed, and it's the electron, I think it's the electron neutrino that we're talking about, that it will have a very, very small mass,
Hmm.
compared, and as a result the other neutrino has a high mass, and that would explain all of dark matter. And he says that it's sort of primordial, it's primordial neutrinos, which are very hot. They were created at the time of the Big Bang, and because they don't interact with through electromagnetic field or with the rest of matter, they're still hot, and um, they're still circulating through the universe. So um,
So,
that's.
okay. Like I'm just gonna this thing he. I guess when was this article written? Big Bang, CPT, and neutrino dark matter. I'm gonna read the abstract.
Yeah, CPT stands
Yeah,
for charge parity time.
one of the
Uh,
most fundamental symmetry laws, I guess, in physics.
yeah. So, and what he did was Einstein, created these equations, and he didn't really relate it to, the field equations that Einstein came up with. He didn't actually relate it immediately to cosmology, but there was another physicist in Russia named Friedman, and he played around with Einstein's equations and came up with this thing called the Friedman equation and applied it to cosmology, and was
Hmm.
able to show that 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 some very simple parameters, that relate to a particular parameter that shows that either the universe is flat, in other words, on the large scale, or it's has a positive curvature, negative curvature, and so that determines whether the universe is closed or open, meaning it's
Hmm.
expanding. So he,
There we go.
so yeah, so it's all related to that. Is that Friedman?
Yeah, he
Yeah, the
looks kind of
Friedman
funny.
equation.
All right.
Yeah.
So the universe is spatially homogeneous and isotropic. Cosmological principle, blah blah blah. Scales larger and metric of the universe must be
Yeah,
deformed.
so this equation comes from the Einstein equations, and I think he kind of startled Einstein at the time. Was like, oh, I didn't know you could get that out of it. So it was something like that. So that alpha t is this main primary parameter that tells whether the universe is open, closed. And so, as far as we can tell, it's looking like the universe is almost flat. but it
Hmm.
also has this dark energy that's causing it um, to expand. So
So, in Neo Turok's version, is he doing something else here? I guess I'm
no,
not
he
very well
no.
versed
Well, so what he was saying is that, see, the alpha parameter as a function of time. So it would
right
go.
here.
I
Yeah.
think what he's saying is he has a mapping of it where it's
Hmm.
smooth and then it goes through zero and then goes negative, and so there's another solution that's on the with time in the other direction,
In the other direction.
in the other
Wow.
direction,
Okay.
and so that's where that and so that's where the where the this this mirror universe,
That
mirror
is.
Big Bang, and the Big Bang is at the mirror point, and so it expands in time, and we're on the side where time is increasing, and there's
Hmm.
another universe, a mirror to us, and it's not clear to me whether he actually thinks it's a real thing or whether it's a calculating a device for calculation, because physicists do learn about in electromagnetics, in electrostatics, we learned about this thing called mirror, um, method of images, where
Right.
you
But
can you know
mhm.
so
uh,
anyway,
so
that's kind of all I wanted to say. I just wanted to point out, I wanted to have people have a look at Neil
here,
Turek,
let me
and
put up his little bio here.
yeah,
This is what he looks like
yeah, so check
right
him
now, at
out.
least.
Yeah,
So,
and
okay, yeah. So go ahead. Sorry.
that's all. I just wanted to have a short show tonight and talk about Neil Turek,
He
and
also worked with Stephen Hawking. We need to mention that a little bit.
he did. Yeah, they were uh they
The
developed certain
Hawking Torque
solutions. Yeah, certain
Institute
solutions. So
solution.
he did know. I'm not even sure. He may have been his student. I'm not sure.
He
No,
the
no, no,
Hawking
no.
Torque Instat
Hmm.
Instaton solution,
Yeah,
which according
yeah. I
to
don't know
the
what
Higgs
that is.
boson
That's
can
something that we'll have
describe
to
the
learn about.
birth can describe the birth of an inflationary universe.
Right.
So
So
if
so
mhm,
Turek is critical of this thing, this other thing called inflationary theory, which is sort of like some kind of hack that kind of tries to explain what happened in the time between when the universe, when the
from
Big
10 to
Bang
the negative
occurred.
36 to
Yeah,
10 to the negative
and
36.
this very
Yeah,
small period of time where the universe just kind of expanded quickly. So he's very
yeah.
um, critical of that. He's critical of string theory and also of supersymmetry, and the reason that, so supersymmetry is that idea that all the standard model particles, electrons, quarks,
Hmm.
and mu and then photons and all the other particles, muons and so forth, that they have a mirror that has very, very high mass, and that was one of the things that the Large Hadron Collider, the LHC super collider in Europe, was supposed to investigate. So they built that thing, and they found the um,
What did they find?
the um, what's it called, the boson, the Higgs boson.
Higgs boson.
Right,
Yeah,
which
yeah,
was predicted, like 60 years ago, and so actually, Higgs is still around, apparently, also at Edinburgh. But so Neil Turek is like sort of, you know uh, his his colleague there, but they so the Higgs boson was predicted back in the 60s, and so we've spent all this time trying to produce it, trying to discover it or uncover it in super collider experiments, and they built this $10 billion thing, $10 billion collider in Europe, and they found the Higgs boson, and they were hoping to find other things. And so one of the startling things about what has happened right this time, this period of our history,
hmm
is that there aren't any other particles. They thought, all of the people, there are thousands, like an army of people who were studying this idea of supersymmetry, thinking that there was another branch of the standard model periodic table. It's like a little periodic table of subatomic particles, that we talked about a few weeks ago.
We did. I
And
mean,
and so we said there's a thing called supersymmetry, and so what we're coming to grips with in the past 5 years now is that there aren't any. That theory is almost falsified. So it'd be very surprising if anything came out of the the LHC. So this is one of the things that he was talking about. So that's why I actually think that there's something to be said for sticking to, as try to bound your physics. If you're studying physics, you want to bound your predictions and processes based upon things that you can observe, and I think it's kind of like almost a signal that if you have a theory and and you're putting things into it, complicated things into it, and then you're not making predictions that can be verified, there's something really off about your theory. So
yeah, no, that
yeah.
makes sense.
So he has a model. He was in this video that we were talking about. He has a model where there's 5 parameters, and he says that's all there is. And so anyway,
so for a longer extended talk where you could actually see his face, where he's actually talking, what's a good YouTube video, Leonard?
Oh, I would start with this one called The Astonishing Simplicity. I think
Astonishing
simplicity of the universe. Yes, I think it has millions of views. It's a video.
Okay. Yes. Well, I mean, that's exactly what I was saying. Like, let's see here. Oh, and it's an hour and a half long. It's
right.
Much even a simplified lecture.
And I think it's fair. It's fairly penetrable. I mean, he's still. I was talking to you earlier about it. I feel like he's a little bit sloppy with the background, and he'll use acronyms for things.
This is what I'm talking about. You know what? Okay. I might as well see if I can just share it. Let me see if I can. I play a little bit. Let me see that. Okay, so this is the one.
The title of my talk is "The Astonishing Simplicity of Everything," and I have to begin by saying that I told this title to a friend of mine a week ago, who has teenage kids. And he said, "Oh, yeah, the world seems pretty complicated to me." And so I'm going to be very careful by defining what I mean by simplicity. I hope to share with you some of the most amazing discoveries we have made recently about the universe, and the fact they're pointing us in new directions for our understanding of the universe.
This video itself is an hour and a half long. I'm only playing 2 minutes of it. I'm going to stop.
Well, for a physicist, simplicity means, or simple
wait for him to finish.
Yeah, that's enough.
Which unify.
That's enough.
Yeah, that's enough. I mean, let people let's not copy their stuff. They did work on that. So
yes,
we'll let people
allow to take a little bit of a clip, but not play more than like a minute or 2. But essentially, I mean, you get his style. He seems pretty down to earth, and he's just talking to you as if you're like an average person, which most people are that obvious is.
But follow up on some of his work and see if you don't agree that down to earth. In other words, he wants to keep his research program, and he's the people he hires and so forth are people who are not off trying to invent all these parameters that you can fit. Because if you have a lot of parameters, you can.
What ends up happening?
Well, you can reproduce any physics that you want, So if you have enough parameters, then you haven't explained anything. So a theory with explanatory power would be able to make predictions about things that have not been observed, and that when you go look, you see it, right? And the model of that is Einstein's prediction of aberration of light. And
like
curvature.
You're saying general relativity and gravitational lensing.
Gravitation, that is the model of all that. And we're not doing that. I mean, I don't think particle physics, the classical particle physics is doing that. So Neil Turok has kind of called them out on that. That's my perception. So
Neil Turok has called them
yeah,
out on that, quoting Leonard.
I think
Called
that
them
we are. I think he would be comfortable with that if Yeah,
Well, you're calling it out too, except
I am.
you're
Yeah,
oh, I thought it would go to the
has
second line. Whatever.
called them
Neil
out on
Turok.
that. Yeah, Neil Turk. Yeah, I mean, and so he actually did say something about the multiverse, and he says the multiverse is the ultimate failure of physics of a theory. It's the ultimate theory. Well, I have a theory where everything happens for some reason.
Okay.
Okay, and if something happens, then I have a universe to explain it. So you might as well be reading a comic book.
Well, a lot of comic books do talk about multiple
Yeah, Doctor
universes.
Strange. Yeah.
I mean, it seems every sci-fi comic book these days throwing a multiverse in one of those, episodes somewhere.
Uh-huh.
I don't know why.
Well, because it's
So
emotionally it's fascinating. I mean, the whole idea that, oh, you mean there's other universes, and there's some universe where I'm actually having a good time, something like that,
it's comforting in a way, I suppose.
Right.
I mean,
So.
I thought
Anyway,
about
that's
it.
all I wanted. That's all I want to talk about. I didn't want to talk about. I mean, I don't know enough about the physics and the stuff. I mean, he's a very smart guy, and I would encourage people to have a look at that particular video. The astonishing simplicity. It has millions of views. People have already listened to it. And
I'm gonna
if
have
you're
to
in,
watch that.
yeah,
That's for
if you're physically bent, if you're interested in physics and the idea of cosmology, I think that you could do worse than to follow him. So
Okay.
that's all.
That's a good point. So anything else of note?
No.
Interesting. So, okay. Well, should I talk about something really weird?
Sure, I'll entertain you. We want to talk about something.
You will entertain me.
Look. I have a motive to try to shorten these talks because I think we overburden our audience.
That's
like when
very,
we go
very
on for an hour or so, because we've gone on for hours, and although we're having a good time, and I'm having a good time, I have this idea that we should be trying to.
So, okay, sounds good. Do you want to hear about alien bodies in Mexico,
absolutely,
or a weird USB stick in Germany that has stuff?
I think the USB stick. What is it, like haunted or something?
No, it's just a stick. Yeah, no, I want to talk about the alien bodies because they actually did this in Mexico City, where Mexico's Congress, heard about these guys showed slides of supposedly alien bodies.
Oh, yes, actually, I did read something about that. I don't know where I read that. I may have just read that on the internet.
So, I mean, like in some ways, you'll be like, why are they doing this? But it must
Don't these people have something better to do?
It must be taken to a certain degree of like possibility for. Anyway, let me just read this, okay?
All right.
So Mexico's
Congress. Slow. Now, when you read slowly. Put little gaps between each of the sentences. Try to. Okay.
Enunciate.
Right. Enunciate.
Clearly. Mexico's Congress heard from researchers on Tuesday who declared authentic set of three-fingered Peruvian mummies recently presented as potential evidence of non-human life forms, while declining to certify that the remains were extraterrestrial. Mexican journalist and UFO enthusiast Jamie Maussan, Meussan, hosted a second briefing on unidentified flying objects at the Mexican Congress in Mexico City on November 7th, 2023. Lawmakers first heard from him on September 13th, when he presented two specimens in a first-of-its-kind congressional event on UFOs, or FANIs in Spanish. I'm not sure what the acronym is. But anyways, Maussan said the bodies believed to have been found near Peru's ancient Nazca lines were not related to any life on Earth. A Tuesday session, Maussan was more focused on proving the bodies, which were not on display this time, were not fake, ushering in a string of doctors who all said the bodies were those of None of the scientists say the study proves that they are extraterrestrials, but I go further, he says, suggesting that it could be evidence of non-earthly life forms. Anthropologist Roger Zuniga of St. Luis Gonzaga National University in Ica, Peru, said researchers had studied 5 similar specimens over 4 years. They're real, Zuniga told formations of these beings. He added, saying he didn't know the origin of these beings. Zuniga presented a letter signed by 11 researchers from the university declaring the same. The letter made clear, however, they were not implying the bodies were extraterrestrial. Massan's first presentation was criticized by many experts who dismissed it as a stunt, long debunked by the scientific community, pointing to studies on similar remains that concluded the specimens were modified using animal and human bones. When asked about those studies, Zuniga said the specimens were probably fake. The bodies that he and the other university researchers looked at, however, were real, he said.
There were better fakes.
Congressman Sergio Gutierrez from President Andre Manuel Lopez Obrador's ruling Morena party called for a reform to Mexico's law to make all information about UFOs public. Tuesday's session at times dipped into a more extreme explanation. Argentine surgeon Celestino Adolfo Piotto said he believed, after reviewing test results and that they were an evolved version of today's human beings, calling themselves our descendants. So, time travel? I don't know what just happened here. Like,
I don't know. I
mean,
I'm
Leonard says better fakes.
My fakes are better than your fakes, you know. So
I'm gonna have to look. You know, I could look. I'm not an expert in human biology, so I could look at these images and specimens, and I would have no idea. But
I mean, you could write a story about anything and probably get, you know, like maybe somebody could go and get a colonoscopy and they discovered that there's an alien civilization inside somebody's colon. You know.
My gosh. Wow, that's taking it to the extreme level. But
yeah,
I mean,
you would get people would click on that, wouldn't they?
They would. But I'm saying like these images and things. I mean, you could, you know, no doubt that these could be like ancient remains of some organism. I'm not saying that's fake, but the question is taking it a step further and saying
so they're trying to say that these are from Peru, right? So they're from Peru, which connects them to the Nazca lines. You know about the Nazca lines?
I do, since I like weird stuff like that. And the Nazca lines is for those viewers who don't know, Nazca lines are mysterious lines in Peru that some people believe are created by aliens, because, you know, how else would you have made them, right?
Well, you make them by moving the rocks out of the way.
I don't know. I'm just saying, like, that's what some people think. But it's because, like, we assume that people of those times can't possibly make complicated geometric shapes, because they somehow have to observe them from air to be able to make like a spider.
Yeah, I don't actually think that's true. I think I could get a Cub Scout, a Boy Scout troop to. I mean, to do
they are like pretty impressive. Like, this is up in the air that you can, you know, they made like hundreds of kilometers, like hundreds of miles of these. So, but point is, there are some people who believe that, hey, these Nazca lines, they're so intricate and probably require some alien civilization or alien help, UFO help, to be able to
people who have never had like an original idea of their own, they can't possibly imagine anyone else having it, so it must be aliens, right? So
wow, okay. That's pretty funny you say that. So if you don't know how to draw, then you might think aliens did.
Yeah, that's right.
So and then you could be like, hey, we kind of discovered these weird organisms that we can't explain, so those probably are aliens too. Around these Nazca line formations.
I don't have enough information. I don't have enough to get a grip on any of this to really say what point they're making. I didn't even really hear anything that was of any any significance, you know, other than Well, it's the Congress in Mexico, which means they're just as.
Well,
I mean,
do you want this is brought up in Congress?
I'm sure I know stuff like has been brought up in the U.S. Congress.
Similarly, in terms of
Yeah.
like extraterrestrials and UFOs and
Mhm.
such. Well, I'm not gonna say, hey, like we should just, never talk about it. But I do wonder,
Just
what kind
let's
of evidence you have to bring in order to,
never talk about it, but it depends upon what the it is. So I need to see the it
okay.
so that I can understand what it is to talk about.
All right. If I was really motivated, I will contact this journalist guy who says they're extraterrestrials and see.
Well, get motivated. I think that's a good idea.
You really think? Okay, maybe.
Yeah. See if he'll write you back. Yep.
Yeah, why not?
Tell him we have a podcast. We were talking about him. Send him a link to the podcast.
I think I might actually. I'm pretty sure he'd be very enthusiastic if he cares to share
Maybe we
his.
can get him on the show.
Oh my gosh. Okay.
Well, we're not going to get Neil Turok on. That would be nice.
I
actually would like to talk to him.
How do you know?
I don't know.
Do you know anybody from that institute?
No, not really. I really would like to talk to him though.
You know what?
Maybe I'll write to him.
Yeah. Leonard, you're illustrious enough, right?
No, I don't know. Maybe. I mean, I could email him and think about what I want to say. But I think I need to study his work a little bit more, and I could do that.
I mean, Neil Torek's email is easily found by
his
institute's website.
Mm-hmm. Right.
So, but I'm sure he gets a lot of emails. So
I know, and I don't want to consume a lot of his time. So.
Yeah. All right. So I'm gonna track down that journalist. Email, and Leonard, we can think about whether we like legitimately get Neil Turok on, if that's that's a possibility we can entertain. Might be an interesting thing to do. Mm-hmm. So for everybody out there, feel free to read some of his popular books, Neil Turok, that is. So he has written a bunch of, besides giving video lectures, he's also co-authored a popular science book called The Endless Universe.
Yeah.
You might want to check that out. And also he has these Massey lectures given in Canada. Massey, and it's published as The Universe Within, From Quantum to Cosmos.
Yeah.
So the universe within.
And I wanted to repeat, so the real reason that I got so interested in him was that he was saying some of the same kinds of things that I have been thinking about, string theory and these other things. And then the fact that the Large Hadron Collider has not discovered anything, except the Higgs boson, and then there has been nothing. Right.
I mean, when you go ahead.
So the reason that's important is because it means that really we're on the wrong track, and that he represents a way of getting back on track and making progress.
Check it out. Look at his beautiful book.
Mm-hmm.
I mean, that's
it
makes you just want to read it, right? With a cover like that. Definitely judge a book by its cover if you want. So anyways, it's only $11, not terrible. You can get it. So any case, only 12 left in stock. Huh, interesting. All right, with that said, what do we end this show with?
Oh, I don't.
All right. So everybody look up, because you never know what you'll see.
Right. Yeah.
Leonard seemed to have forgotten that, but that's fine.
Yeah.
All right.
I do get a little tired,
I understand. I mean, nighttime is arriving earlier these days, it seems, with time change. Here we are, the daylight savings time or whatnot. You've been listening to SG2 on Space Only Weekly Space Show. This has been episode 196, where we went over very briefly talking about Forex, who he is, and the profound ideas that he brings forth. With that said, we'll be back next week, as always.
We will.
And, you can find us on YouTube. Like I said, look up SG2 on Space, or you can go to youtube.com/ShenGe/podcast, and, you find it. Like, subscribe, share, all that good stuff. And support the show, patreon.com/SG2 on space. And with that, I will say
Namaste.
namaste.
Shalom.
Good night.
Good night. Mwah.
I knew it. That was going to happen.